Hi everyone, it's great to be here. I'm Aviram, co-founder and Chief Product Officer at JIT, the continuous security platform for developers. In today's talk, I will present the minimal viable security mindset, and I'll show you how to implement it to secure your cloud-native app using few open source solutions. Thank you for joining me, and I hope that in 15 minutes from now you look back and say, wow, this was awesome. Let's start. We are familiar with the MVP concept, right? Minimal viable product. It's an iteration of the product that comes with a minimal set of features needed to test the market and make sure that what we are building is viable. When developing MVP, it is done iteratively. We focus on delivering a minimum baseline value in every single iteration. MVS is very similar. It means that we look at security requirements the same way we would look at features to develop as part of the MVP, starting with clear value, but at the same time lean, and gradually improving it in a continuous and agile manner. The MVS plan is therefore a concise but viable security baseline. MVS plan should address the attack surfaces of a modern cloud-native app, and oh boy, there are so many. Here are a few areas that the MVS plan should address. The code. The code is absolutely an attack surface. For example, hard-coded secrets can be easily exploitable. The infrastructure is also an attack surface, whether it's the runtime infrastructure or static, like with infrastructure as code. The application runtime is an attack surface, also the pipeline, the CI/CD pipeline, the data itself, the data that we store, that we manage, third parties that we use. The people themselves are an attack surface, social engineering, right? And operations. Operation and procedures could be also part of an MVS plan. For example, having a defined incident response process. All of these are highly important and can be considered minimal. Do you think otherwise? Something is missing here? Let's discuss. I will now walk you through the implementation of a major subset of the MVS plan. Not all of it, just 6 categories. We will review dependency check, secret detection, container scanning, application runtime scanning, infrastructure as code scanning, and cloud environment scanning. So first category, dependency check. The reason we should implement it is to detect publicly disclosed vulnerabilities contained within a project dependencies. There are great tools to detect node vulnerable dependencies. Here are 3 of them. In this example, we see that there is a dependency named ADM zip. It's a JavaScript implementation for the zip data compression for Node.js. And ADM zip is used in this project. And the dependency, I tell you, contains vulnerabilities. You can see that in this example, the tool that we ran was able to detect this dependency and mark the severity as critical and also associated with the description, the CVEs of these vulnerabilities. The next category is secret detection. The mission here is to detect hard-coded secrets in various formats such as password, access keys, API tokens, credit card numbers, and more. This is a very important tool as part of the security arsenal of anyone, and it's a crucial part of an MVS plan. Here we can see 3 popular tools: Git Secrets by AWS Labs, Detect Secrets by Yelp, and GitLeaks, which is owned by individual developer. All of them are good and free. We recommend, by the way, GitLeaks due to its high detection rate and easy integration in the CI/CD. This is how the output of Git leaks look like. The next category is container scanning. The mission here is to detect vulnerabilities and configuration issues in container images. We recommend two tools, Trivi by Aqua and Claire by Kowai, part of Reddit today. Here's an example of Trivi's output when scanning a Docker image that I created based on Debian 11.3. Next category is the runtime scanning. The mission here is to detect vulnerabilities in web application while running. That includes API scanning, and it also includes web app scanning. It can run in non-authenticated mode, what we call black box testing, or authenticated mode, the gray box testing. Here we checked few tools. These are three of them. Zap, by the way, OWASP Zap is the most popular tool. It is maintained by the OWASP Foundation, and it has been with us for over a decade. We chose it due to its feature, specifically the authenticated and non-authenticated web app modes and the ability to scan API. By the way, Zap is also supported by a large community. So in this case, we can see that Zap scanned the web application and detected that the content security policy, what's called CSP, the header is not present in the server response. And essentially, CSP is used to prevent cross-site scripting, click checking, and other code injection attacks. So it's great that Zap found it. Next is Terraform Scanning. The mission here is to detect security vulnerabilities, cloud misconfiguration issues, and compliance issues by analyzing infrastructure as code. We have compared also several tools here. The top were Checkov by Breachcrew, now Palo Alto, Kix by Checkmarks, and TFSec by Aqua Security. The good news, by the way, is that all these tools are great. We decided, by the way, to go with Kix because it exhibited a very good rate of true positive and low rate of false positive. So in this case, we have a Terraform module where the EBS data is not encrypted. You can see in this example. And Kix identified this misconfiguration and it ranked it as medium, together with sharing details about what this vulnerability misconfiguration is about, and also provided some guidance how to fix it. And last one is the cloud runtime scanning. The mission here is to detect vulnerabilities, compliance issues, and infrastructure misconfiguration in the runtime cloud environment. The best tool today is, with no doubt, Prowler. It supports more than 200 checks, covering CIS benchmark, PCI DSS, ISO 27001, GDPR, and other. It is focused on AWS cloud, and it's a very, very powerful tool, highly recommended, and we recommend using it. We think it should be part of your security arsenal, and it's totally part of the MVS. So I picked 5 of the security tools that implement part of the MVS in a GitHub action file, and I added it to this repo, so you can go to this repo and you can clone it and review the YAML file. I'm going to show you how it looks like. So this is the repository I prepared for this demo. Here you can see the security YAML. In the security YAML, I included 5 security tools. All the jobs here will be triggered by push, by commit, and the jobs are There is one for secret detection. It will run git leaks. For DAST, dynamic scanning, it will run the proxy. For infrastructure as code, it will run kicks. For SCI dependency check, it will run the OAuth dependency check. And for container scanning, it will run Trivy. I also included in this repo a few files with misconfigurations and vulnerabilities, so you can play with it, create a commit, and then see how these jobs are executed, and you'll be able to see them and the results under actions. So at JIT, we took it to the next level. JIT is a continuous security platform that orchestrates open source solution in order to address the security plans, and we take the user in a journey to implement security, starting from MVS and continuing to more advanced security plans, and all the implementation of the security solutions is done totally automatically by JIT. And by the way, we provide also dev native experience using pull requests. So for example, developers who create pull requests, they will be able to consume the findings and the data through the pull request, through security review. Very native experience for developers, and by that we want to promote the implementation of security gradually, and this is what JIT does. So that was it. Thank you very much. I hope it was interesting for you, and I will be available later on to answer questions and to discuss issues if you want to bring them. Thank you very much, and goodbye.